So exponents. It says rewrite each expression in exponential notation. So we've got to talk about some things here. So the first example says 7 times 7 times 7, which is equal to 7 to the third. An exponent is just a shortcut to writing out a list of multiplication. That's all it is. Okay. So the base is 7, and the exponent's 3. Nothing earth-shattering there. Expanded form, okay? The name says it. Okay, it's expanded out. It's got that big, long, sort of math kind of sentence. And then exponential form is nice and condensed. You've got your base and your exponent. So in that first example, base and exponent, raise your hand. Who's got it? Jacob.
Base is 5.
Yep.
Exponent is 6.
1, 2, 3, 4, 5, 6. Okay. Number 2. Yeah.
9 sevenths. The exponent is 4.
Perfect. Number 3. Number 3, Kate.
Negative 4 11.
Yeah.
Base.
Uh-huh.
And the exponent is 3.
Perfect.
Notice what I did on how I wrote it. I put that negative 4 11s in parentheses. Put it in parentheses. Claire.
It's negative 2.
Yeah, make sure you got the parentheses.
The exponent is 6.
Sure thing. Okay. So the vocabulary. So the number, oops, did I miss some vocab?
Yeah.
Oh, did you notice that the parentheses in 2 and 3 and 4, why do you think there are parentheses? And I said something. I said make sure you put them in. Why do you think we need to put them in? Lucas?
Because it's negative.
Oh, okay. Because they're negative. So what's that going to do to our final answer? Okay, it could be a positive. Our answer could be positive. Okay, so we know our exponent rules. A negative times a negative is a positive, but a negative times a positive is a negative. Okay, so we've got to think about our integer rules. Okay, our integer multiplication rules. And a negative times a negative is a positive, but a negative times a positive equals a negative. So let's do. Number 2, what did you notice about? Oh, number 2 is just that there is a what? It's just a fraction in that. And I guess when you write that, so let's make a little note of that. The number 2, there's a fraction. No negative, but it's a fraction. So when you write that in exponential notation, putting that in parentheses is certainly not a bad idea, because watch if I take away the parentheses, what could it look like? Don't write this down, just look at it. If I take away the parentheses and do that, what could somebody think is being raised to the 4th power from it?
9 to the 4th power.
Yeah, you could think that it's just 9 to the 4th power. So the parentheses do make a difference here, so we should put those around that. Let's talk about number 3 and the parentheses and the fraction. So I said make sure we do this. So let's just look at the sign there. What's a negative times a negative? Positive times a negative is negative. So my final answer is negative. What if I take away the parentheses? And from, let's see, let's back that up. What if I wrote, what if my initial problem was this? I don't want to write it. What if I take away the parentheses there? There.
It would look like you were trying to do negative 4 to the 3rd power.
Right. Okay. Negative 4 to the 3rd power. Or somebody could mistake it and say negative, they could think of this. okay, where the 4/11 is being to the third power and not the negative. Okay, so those parentheses are grouping symbols. Okay, if they're there, put them there. If it's a fraction, put them there. If it's a negative, keep them there. Right, because it does make a difference, and the calculator will pick up on that difference too. Because sometimes you'll say, oh, well, I put this into the calculator and gave me this, but I know it's not that. And I say, well, then there's a problem with the user, okay, not with the calculator. All right, Bart, what do you got?
Oh, so I don't get why you need parentheses for just like single number.
Okay, all right, so let's look at that one. So I'm going to, so I don't have to write it out 6 times. What if I have that? What does that right there mean? If I expanded that out, what is that equal to? What? Okay. Negative 2 times negative 2, which we all know is equal to what? Positive 4, right? What if I take the parentheses away? What does that mean? Okay.
2 times 2.
Times a negative. Because what's being raised to the second power right now? Just the 2. Okay? So that's really a negative times 2 times, times 2, which is negative 4. Right? Big difference. So that's why, good question on why you need them with just a single number, not a fraction. Okay? All right. So this one. Will these products be positive or negative, and how do you know? A negative 1 times itself 12 times. If I have an even amount of negatives multiplied out. Is that going to be a positive answer or a negative answer? Alexis? Positive. What about if I have negative 1 times itself 13 times? Tell me. Negative. Why is that?
Because it's an odd number.
It's an odd number. Okay? If I have 2 negatives, negative times a negative gives me a what? Positive. But if I have a negative times a third negative, okay, negative times negative is positive, and then a positive times a negative is. So when you have, let's summarize, an even amount of negatives, answer is positive. But if you have an odd amount of negatives, your answer is negative.
Hey, why though?
What's a positive times a negative? It's negative. Okay? When I have an odd amount of negatives there. If I have negative times a negative, it's a positive because I have, because I have an even amount of negatives. Okay. All right. Oh, did I miss this little summary box again?
Yeah.
Okay. Go back. Sorry about that. Vocab. The number x to the n is called x raised to the nth, okay, power. N is the exponent and x is the base. Nth power, that means could be anything. Okay, nth power. Okay. All right, now let's flip it. Product and quotient rules. So let's expand out 10 to the 6th power. I need to expand it out. What am I going to write? 10 6 times. I'm going to use, what do I want to use? I don't want to use the x for multiplication. We're really kind of over that. Okay. I'm just going to use the dot. 1 2 3 4 5 6. 10 to the 3rd, right? So now it's saying expand 10 to the 6th times 10 to the 3rd. Isn't that just all of that, oops, times, get rid of all of that. Let me get this out. Yes, it would. What do we notice? I just copy and pasted mine because I didn't want to write it all in there. What do you notice? Yeah, it's just like,
You're adding it on to, so instead of like, so 6 plus 3 is 9, so it'll be 10 to the 9th.
that's exactly what it is. Okay? So this, okay, we took the 10 to the 6th, brought it down, and now we took the 10 to the 3rd and brought it down. So Matt's saying, isn't that just 10 to the 9th? So we have 9 10s here. So he said it, what do you notice? You're adding the what? What were we adding? The exponents, Jacob, thanks. Okay? We're adding the exponents. So if I were to take this and put letters to it, same thing. What is a to the 4th? If I expand it out. A times itself how many times? 4 times. A to the 5th is what?
A times A times A times A times A.
Okay? So then it says expand A to the 4th times A to the 5th. Claire?
You're adding the
Yeah, it's just A to, let's see, let me try this a different way. I'm going to see if I can copy and paste. If I copy it, yep. I don't even know how to paste it on here. Nope. I copied it, but I don't know how to paste it. So,
You have to go to your computer.
yeah, that's what I was thinking. So, 4 of those guys, 5 more, gives me A to the 9th. Again, what did we do? Add the exponents. Nothing earth-shattering, right? So it says, when you find the product of 2 algebraic expressions, with the same base. Okay, notice we had A here and A here. That allowed us to do that. Back up here, our bases were the same, 10 and 10. We could add the exponents. You can add the exponents and use this exponent with the same or like base. So what could I say this is equal to? A to the m times a to the n. What could I say my answer is?
A to the m plus n.
Yeah, a to the m plus n. Don't say mn, because mn would indicate doing what with the m and the n? We're multiplying. We're not multiplying the exponents, we're adding. Simplify each expression. It says write it in exponential notation. Who's got number 1? Bart.
-4 to the 5th.
And what do I need to put around that -4?
Parentheses.
Yeah, -4 to the 5th. Number 2. Tony. Awesome. Okay, there's a 1 as an exponent for that 3. So it is 3 to the 7th. Number 3. Dane.
A to the 32nd.
A to the 32nd. Okay, number 4. Alexis. 1/5 in parentheses, 17th. Number 5. Number 5. Come on, guys. These are quick. Matt, see.
Negative c to the 12th in parentheses.
Awesome. Number 6. Claire. Perfect. Pretty simple, right? Adding the exponents. All right. I'm going to pause this and we'll come back with the answer. All right, so let's move down. So 5 to the 6th power, expand it. What does that mean, Alexis? Hmm? And 5 to the 2nd, we know means that. Now it says expand 5 to the 6th divided by 5 to the 2nd. So if I did that 5 to the 6th divided by 5 to the 2nd. Guys, what is 5 divided by 5?
Oh.
It's 1, right?
Yeah.
What's 5 divided by 5?
1.
1. What am I left with?
4 and 5.
Yeah, 4 and
5 to the 4th power, right?
Oh.
Hold it. Hold it. I think you're seeing it. Let's do this next one. Y to the 7th and y to the 4th. Means y times itself 7 times. And y times itself, how many times? 4 times. But now what if I divide them? What is y divided by y? 1. What's y divided by y?
1.
And I get it here
1.
and there. So I'm left with y to the 3rd. Tony, what do you notice?
We're subtracting exponents.
Exactly, subtracting exponents. Okay, so what do we notice? We are, okay, so when we divide, we are subtracting exponents. When you find the quotient of two algebraic expressions with, again, the same base, you can subtract their exponents and use this exponent with the like or the same base. Common base. Oops. Saying it and writing it here. Same base. So, in general, a to the m divided by a to the n is what? A to the m divided by a to the n. We said when we have like bases and we divide, what do we do with the exponents? Subtract it, so tell me what to write. Okay?
A, M, minus N.
A to the m minus n. Because the exponent is the m minus n. A is the base. Okay. All right, let's practice. Simplify each, write it in exponential notation. Who's got 13? Alexis. 2 to the 3rd. Like bases, subtract the exponents. 14. Claire. Careful. Parentheses, negative 7 to the 4th. 15. Jacob.
3.5 in the second column.
16. 16. Lucas.
16.
Yep.
5 to the 8th.
In parentheses.
Parentheses 5 to the 8th divided by 5 to the 8th. No, 5 to the 8th, 6 divided by 5 to the 8th.
You just read the problem. What's my answer, Alexis?
5 to the 8th. 5 to the 8th.
To the 5th power. Okay. Thank you for saving Lucas from himself on that question. 17. 17, Kate.
2 to the 5th.
2 to the 5th. 18. Bart.
Parentheses may repeat to the second.
Okay? 19. Roman.
H. Okay.
Yeah, there's like a 1 there and a 1 there. You didn't have to put the 1. He just said HK. That's fine. Absolutely. Okay? What about 20? 20. Ethan, 20. Do the division.
4M to the 4.
Good.
And to the second.
Excellent. 21. Lily.
7x 6.
Excellent. Okay? We're done.